Assalamualaikum and good day everyone. I'm Rashida Arazi, PhD student from Chemical Engineering Studies, College of Engineering, UIT Penang. In this video presentation, I would like to introduce my new innovation works entitled CCF28O perovskite heterogeneous catalyst for efficient degradation of caffeine micropollutants. Basically, these innovation works involve a research collaboration between UIT Penang, the University of Sydney, Australia, and University Science Malaysia. Caffeine is regarded as the most prevalent psychoactive drug used globally, with an estimated consumption of around 120,000 tons per year. Removal efficiency of caffeine for conventional wastewater treatment plants was found to be between 64 to 100%, with primary treatments accounting for only 10% or lesser removal of caffeine. Wilkinson in 2022 reported that caffeine was found in more than 50% of the 1,052 sample locations spread across 104 nations on several continents, making it one of the main pharmaceutically active compounds, micropollutants with the highest concentrations in river surface water. Caffeine has been reported to be endocrine disrupting chemicals and contaminants of emerging pollutants that could cause some adverse effects to human and aquatic life. Advanced oxidation process has been broadly used as a water or wastewater treatment methods due to the generation of the hydroxyl radical, which can rapidly and non-selectively degrade a wide range of organic pollutants. So in this work, perovskite catalyst has been utilized as a heterogeneous catalyst to degrade caffeine from the aqueous solution in the presence of hydrogen peroxide without the need of light irradiation and no pH and temperature solution adjustment. So what is perovskite catalysts? So basically, perovskite catalysts are the crystalline ceramics that belong to the group of mixed oxide with the general formula of AbO3. So from the literature, it has been reported that the catalytic activity of the perovskite can be significantly influenced by the partial substitution of the transition metal into the B sites of the perovskite structure. Hence, in this work, partial substitution of copper into the B side of the calcium iron oxide perovskite catalyst was synthesized via a combined EDTA citric acid compressation method. So the results of the catalytic performance of the calcium iron oxide here, demonstrate around 24% of the caffeine degradation or caffeine removal in the presence of the B site substituted calcium copper iron oxide, which is the CCF28O perovskite catalyst, shows a complete caffeine degradation was achieved within 4 hours of reaction. The result of this work basically have surpasses the findings obtained from the literature by CIMSEC here in 2020 using the platinum iron oxide perovskite catalyst with only 11% of caffeine degradation. Such observation reveals that copper substitution into the calcium iron oxide activated hydrogen peroxide to accelerate the generation of the radicals, resulting in a much higher rate of caffeine removal. Interestingly, as confirmed by the EPR analysis, CCF28O was effective in producing the hydroxyl radicals, which is responsible for the decomposition of caffeine. So the identification of the caffeine's intermediate compounds during the reaction was determined using the GCMS analysis. 3 main intermediates was found for the caffeine degradation, which are N-N-dimethyl urea, here, N-N-dimethyl urea, the methylparabanic acid, okay, and the last one is a dimethyl xanthine. The formation of these intermediates may occur via two degradation pathways, and the caffeine was further mineralized into the methylamine, ammonia, carbon dioxide, and water. In terms of novelty, the CCF28O has some innovative features such as efficient degradation, less energy consumption, simple operation, funded by Fundamental Research Grant Scheme, and also being protected by the copyright and the Intellectual Property Corporation of Malaysia. The estimation of the product cost was calculated to be 360 per kilogram by considering the cost of the raw materials, packaging, utility, and transportations. In terms of commercialization potential, we have collaborated with the KCN Environmental Solutions Neighborhood to provide catalysts for their wastewater treatment, and the proposed or the selling price is 380 per kilogram, with the expected of the profit margin of 20 ringgit per kilogram. This is actually comparable with the price of the commercial titanium dioxide catalyst available in the current market. That's all my presentation. Hope you enjoy and thank you for listening.